Hello, everyone. Thank you for joining us today. My name is Alex Harris. I'm the marketing executive here at the British Plastics Federation. Today, our webinar is entitled Building Cars with Recycled Plastic, Designing with Sustainable Components. And we are pleased to be joined today by Keith Freegard, who is the director and founder of Axion Recycling Limited, one of the UK's leading recycling businesses in the waste materials recovery industry. He's got over 30 years of operational management experience, gained in a variety of manufacturing environments. He's vice chairman of the BPF's recycling group and a non-executive director of OPRL, which is the on-pack recycling label scheme for consumer packaging. He's also been listed as one of the 70 most influential people in UK plastics recycling. He's deeply involved in everything to do with plastics recycling and the circular economy, and basically just working out ways that we can recover and recycle plastic more effectively, which is especially relevant given all the recent attention in the media on plastic waste and the recent calls for evidence from the government regarding ways to deal with plastic waste. So I will hand over to him in a second, just to let you all know that if you have any questions during the webinar, in the box that should have popped up on your screen, there's a little section where it says questions. So as things are going along, just type them in there, and then I'll ask them at the end, put them to Keith at the end of the webinar. So please do anything that isn't clear, or anything you want to know more about the subject he's talking about, just ask the question, type in that box, and then I'll ask it at the end. Okay, so without any further ado, I think that's everything. I'll hand over to Keith.
Good morning, everybody, and thank you for taking a bit of time out of your busy day to join my webinar. It's my first experience of running a webinar, and I must say that normally my presentation is to rooms full of people, and I tend to engage quite with the audience in a way that gets a bit of interaction. So I shall try and make sure that my normal enthusiasm and passion for the subject carries through in the presentation today. And just to repeat, if there's any questions, then please put those in the type-in section at the side, and we'll address those towards the end. First of all, to introduce myself, I'm hoping you've all got my smiling face looking out of your screen. I've had quite a long career, so I've kind of got several different functions in my background. I'm a qualified chemical engineer and a member of the Institute of Chemical Engineers. Certainly I would describe myself as a businessman and an entrepreneur. I've done 3 different startup businesses in my career, many of those involved in packaging and plastics. When people ask me, I guess I'm becoming a bit of a plastic man, to be honest. I'm the vice chairman of the recyclers group at the British Plastics Federation. Certainly I would describe myself as a family man with 26 years of marriage behind me and 4 children who are now students, still massive great drain on the family purse. And also I'm also an Ironman as well, because I'm very keen on triathlon running, and I've been a competitive triathlete for the last 10 years. Anyway, on to the presentation. First of all, I kind of just reference why even bother with all this crazy recycling stuff? Why don't we just carry on doing what we've always done? Talk a bit about the impacts of materials and the way they influence design thinking, and then move on to what the benefits are for designers and specifiers of materials for using recycled content, and then a bit about where you might go and what you would need to look at if you're seeking polymer supply from the recycled marketplace, and then allow myself a few moments to do some future gazing. First of all, I need to really reference what we do here at Axion Polymers. Today I'm speaking from our Manchester plant. So to set the context, it's really useful for me to explain a little bit about what we do, and then you'll understand where the basis of our knowledge and know-how has come. My company's vision is working towards a world where nothing goes to waste. clearly that's a fair way off in the future, but you know, on a simple commercial basis, if in my business there was nothing going out as waste and I could convert all the incoming materials into saleable products, I would have a much more valuable business. My company, Axion Recycling Limited, has two sections to it: a consultancy business, which has been run since 2002, and also our active polymers business, which is where we sort and separate materials. We've grown to, I think now we're about 97, 98 employees. So we've created high value jobs in the green economy. We're turning over a reasonable amount of cash, and we're making our contributions to the UK economy in wages and employment, etc. At the moment, we can receive about 200,000 tons of input material, a material called auto shredder residue, which I'll talk about in more detail. Two plants here in Manchester. I'm sat in Trafford Park today, where we do the primary processing of metals and separating of the non-metallic materials. We have another plant in Salford where we then make finished polymer. And really, we're about advanced process engineering. We're chemical process engineers who just happen to see the waste in feed as our raw material. I think we're one of the leading consultants in the sector, and we're actually delivering the circular economy today. So I shall talk more about that. This next slide is a familiar sight for anyone who spends time trying to drive around the UK, but all those motor cars in a traffic jam, I absolutely love it, because that's my future raw material stored in a metal box that's on 4 wheels on a big above ground warehouse that's being paid for by somebody else. To give you a feel for what happens to motor vehicles when they reach end of life, this is a kind of model of the flow. The last owner, which is somebody who hasn't got a massive amount of cash, who ends up owning a 13-year-old vehicle, will normally ring up a local collection scheme. We are linked closely with a company called Car Take Back, which does exactly what it says on the label. They'll come and take your car, give you some cash for whatever the weight is and the value of steel on that day, and they'll make sure that your name is removed from the logbook for the vehicle at DVLC Swansea. They depollute and remove liquids, and then they pass the flattened vehicle onto a traditional metal recycler, who needs to be somebody who's got a big enough machine that can shred a whole car body up into little bits, and they'll get out the steel and the other big metals like aluminium. And that used to produce something called auto shredder residue, which traditionally went to landfill. But with landfill costs increasing dramatically like they have done in the last 10 years, everyone now is invested in PST, which is post-shredder treatment. And there the idea is to try and get anything out of this mixed non-metallic fraction that you can turn into useful stuff. So we get a stone and glass aggregate, solid recovered fuel, feedstock for our plastics recycling process, and then eventually polymers. So here's a typical pile of squashed cars ready for in-feed into our process, and here's a bright young graduate chemical engineer who's getting some hands-on experience. This next slide shows a car shredding unit. The big structure is mostly, the high stuff is a big air system that sucks away all the dust and dirt that's created when the shredding occurs down in the lower corner of the screen where the cars actually get shredded. There's a big drum magnet to pull off steel. There's a great big eddy current separator to pull off aluminium. And then everything else is auto shredder residue. So ASR, as you can see by this next photo, is not a particularly attractive stuff, because if you think of all the things in a motor car which are not metallic, the seats, the carpets, the roof lining, the glass, the wood lining in the back of the door or under the boot, plus into a shredder, lots of other things go in, like large domestic appliances, small mixed wee, generally collected scrap, building materials, etc. It makes shredder residue probably one of the most complicated mixed raw materials there is in the waste sector. What's good about that is it's not that attractive to anybody else. So unless you spend a load of money and 15 years of your life learning how to sort and separate shredder residue, this stuff is really undesirable. So I don't have loads of people banging on my door every day saying, can we buy some of your shredder residue? The material gets fed into our swap plant, which is here in Trafford Park, Manchester, just about 50 metres from where I'm sitting in the office today. And that's the Shredder Waste Advanced Process Plant, which is the primary sorting and separation of that mixed ASR material. We built that in 2009, and we carry on improving and developing it as we go. And to make a complicated plant look very simple, here's the split of materials that we get. We get an alternative fuel, solid recovered fuel, which is the combustible fluffy fraction. We get aggregates and stone and glass for construction. We get copper, aluminium, a little bit of that out, and then a mixed plastics for upgrade. Steel, you have to have a look at a picture of a steel. I know it's not the prettiest picture in the world, but actually you have to remember that the steel is a large percentage of the infeed, and that was the original raison d'etre for the business. So the company I'm linked with, S. Norton, are big exporters of steel all over the world. They have a docks in Liverpool where they can load 30,000 tons at a time. So steel is kind of the cash cow, big volume material. And we have a plant that looks like this. This is looking onto our plant in Trafford Park and Tenax Road. Why I like this photo, I think, not only is it a sunny day in Manchester, which is rare, but it looks like a really modern technological factory. This is the new image of processing materials that happen to come from the waste sector. It's not a rough old yard of skips. And inside you can see the level of advanced process plant that we designed and built ourselves with our own engineers, because you simply can't go out and buy this stuff. It's all new, it's all leading edge, it's still pretty specialist. So designing it and building it, operating it and running it is what's given us the knowledge we've now got. We then get a lovely mixture of plastic that comes off the end of this swap plant. And hopefully you're all amazed by the fact that this photograph is the material that we've extracted from that horrible looking ASR just 5 slides earlier. And in about half an hour, we've got what I would call an amazing transformation. This material is still all different types of plastic. You couldn't just stick that in an extruder, but as a kind of crude oil waiting to be further separated, it's really useful. And that gets delivered into our plant in Salford, which is only 5 miles away. And then that becomes their stable, steady, constant supply. There's another 20 separation stages at Salford, which I can't explain to you because they're secret and it would take ages. But essentially, we use any basis for separation of the material that we can find, its size, its shape, its density, its color, its reaction to light, etc., etc. And that lets us then get to a level of purity on the main polymers where we can make strand. Here's some strand being extruded, and then we chip that to pellet, and we're beginning to get near the end of waste. And we've then got polypropylene, ABS, and high impact polystyrene available. We still buy in some refrigerator flake. We don't have a fridge plant ourselves, and we make a light colored PS out of that. And then we've got a product. So we can sell that to customers, and we're active in all these different markets. And as most of you will be familiar with the polymer market, you know that anything of any shape, of any component into any product can nearly all be made out of plastic. So that's the background and the context about what we do. But then I thought to myself, well, why bother? Why not just carry on using oil-based polymers that have come out of the ground and be refined by a big petrochem, and then they take those monomer gases, ethane, propane, butane, and turn them into polymers. That works. That's a big volume industry. And you don't have to be amazingly open-minded to realize that things are changing in the world. One of the things I've kind of developed as a habit is following the Arctic ice coverage in the north of the world, because the ice caps are a really important part of controlling the world's weather system. And normally the sun hits the ice and the sun gets reflected and there's a big cold lump of cold air that sticks over the polar ice cap. And to me, that kind of sits there like a huge air conditioning system that tries to keep our world's weather pattern under some control, and the jet stream flows between the equator and bangs into the cold air of the ice cap and then moves up and down, and as we tilt towards the sun we get summer and winter. The graph on the left, which is this year's average temperature graph for the Arctic, is incredibly alarming. If you look at the last 10 years, nearly all of them are way above average, but this year it seems to be going off the scale. And if you had a boat now, you could pretty much sail across the Bering Strait and go all the way up across the North Pole on what should be ice. What impact does that have? I took a photograph on the right, which is this beast from the east, massive cold stream of air coming down, giving us unseasonal weather, and I'm told that at Easter we're going to have the same. So in terms of impact, burning fossil fuels and using fossil fuels to throw CO2 into the atmosphere is having a massive impact on everyone's lives. Anyway, let's not be downhearted. Here's the circular economy, which we have spent the last 15 years delivering for motor vehicles, and the green boxes at the bottom show all the things I described quickly, and the grey boxes at the top are what the automotive sector needs to do to start tapping into the supply of polymers that come from businesses like my own. And there's a whole list of benefits for doing that. So this is a kind of theoretical future model of how the world might be. But the next slide, I'm trying to work out where are we at the moment in terms of actually delivering a ready and stable flow of circular materials into this manufacturing economy in that we all exist. And on the left, I've shown an example that I got from an academic meeting I went to at a university. And there's a kind of still probably theoretical world where raw materials flow into the circle and then they go round this lovely virtuous circle, and they either get turned into new products or redistributed, or we recycle all the materials. And you'll notice that on the left-hand diagram, there is no waste. We're a long way from that. I think this sort of downward spiral diagram that I put on the right is maybe kind of representative of where many material recycling loops are at the moment. In this one, I'm kind of saying end-of-life vehicles. For plastics, we maybe get one good use out of the polymer, and if we're lucky, that material might get another use, and then eventually it becomes waste. I would accept that for metals, this is a much more closed up spiral where the material goes round and round and round. They're much closer to a non-waste model, but for plastics, we're still a long way from perfection. And I think the focus of this presentation and the ethos of my business is to try and accelerate a transition to a stage where we move more towards the theoretical future from where we are now. We've shown that already, so I've doubled on my slides. Oh no, I'm going backwards, sorry. My mistake. So, products, certainly automotive products, I'd call them materials hungry. You know, they weigh 1.3 tons on average. And the materials that go in products have a big impact. So, here's another example of my above ground warehouse. And we've really got millions and millions of motor vehicles that are, quite a lot of them are pretty underutilized. They're either not going where they're supposed to be going at the speed they should, or they're blocking up the roads and the streets of our urban environment. How much have we actually got of this stuff? You know, I tried to do some estimates here. The UK car pool, maybe 35 million vehicles. You've got to decide whether you include vans and coaches and lorries. Average weight, we know that's pretty accurate, about 1.3 tons. And the 250 kilo of plastics is all the polymers on a sort of modern compact vehicle. And if you roll through the numbers on the lifetime, then there's a lot of debate about exactly how many cars arise as waste every year. I think it's about 1.7 million vehicles, even though the official destroyed figure is more like 1.1. And therefore, there's a massive amount of stuff sat in that big mine of vehicles waiting to be mined, and the annual arising is probably 450,000 tons of product. As plastic arisings, might be all mixed, might be complex. If you look at the EU, difficult to get more accurate numbers, but it is around 200 million vehicles, and then that pro-ratas up in terms of the amount of available stuff. So if all that polymer is out there in all those cars, surely we ought to find a way of extracting it at end of life and getting it back into that circle economy that I described earlier. Oh, sorry, I keep clicking my mouse the wrong way. Apologies. It's complex. This is a explosion of all the parts. I can imagine the person who did this probably took all weekend in their garage and then laid all the parts out. It's pretty complex, but the mix of actual materials is very broad as well, and that's shown on the left: metals, rubber, glass, plastics, wood. Putting that in a more ordered structure, about 70% of vehicles are metals, steel and aluminium, etc. And the plastics fraction is about 250 kilos. Depends what you call plastics, of course. You know, if you roll in polyurethane foam, textiles, elastomers, and hard rigid plastics, then that includes the 250 kilos. But then there's all the composites and other complex things there. Even some of the glues and adhesives are probably elastomers. And we have the thing in place called the ELV directive, which sets a high target for recycling and recovery of those materials. You can't hit that target if you just do the metals. But in the motor vehicle industry, times are changing. We will make a transition from internal combustion vehicles, which is shown on this example I found as the gasoline car, to electric vehicles in the next 5 or 10 years. And what this clever person in Holland did, the lady I've referred to down here, is looked at the life cycle impact of running an electric car versus a gasoline car. Now, on the petrol car, all the focus is on the use phase because you're burning fossil fuels and emitting them out the exhaust. On the electric car, the big thing to consider is where did the electricity come from that you use to charge the vehicle? Now, there's two examples here. The top one shows what the mix of power generation was for Holland when this was done in about 2014. That's obviously will become more renewable as they build more windmills, etc. But if you charge the car with 100% renewable power, then when you use that electricity, you're not really responsible for any emissions. So the only emission from driving a electric car charged with renewable power would be a little bit of rubber crumb off the tires, maybe. And at that point, the choice of materials and the manufacturing and putting those together is the entire impact of the car on the environment until, of course, it reaches end of life. So what that means is the correct choice of material really, really matters, and that the duty and responsibility on people building cars is switching from the current main ethos, which is how can we get weight down and reduce emissions of fuel, over to what is the impact of the materials that I've chosen and how am I going to put them together so that when that product reaches end of life, I can get those materials back. If they're charged up with renewable energy, that part of it's done. So what are the various impacts of the choices the designer makes when they want to build their lovely new shiny model that's going to sell loads? A new electric version of something like maybe the Nissan Leaf or a new electric version of the Volkswagen Golf. That's the big volume area. Certainly, I think it's clear that the decisions made at the design stage really live with the product for the whole of its life. So lightness, efficiency, the way you fit those together to make a really slippery shape, that has a huge impact on the life cycle impact of the product. And when you select each material, you need to really think about the embedded carbon cost that came with that. I know that in the last few years, aluminium has been replacing steel to a large extent to get vehicle weights down, particularly on larger, big saloons. But the problem is you maybe get the weight down and make some savings on the in-use fuel emissions, but you bring with the aluminium, I think it's about 10 times the carbon impact of buying steel, and steel is largely recycled. So there's a really much more difficult quantified balance to be made when making those choices. And I really don't think that much of the design industry has switched onto this idea yet. How you fix those things together when you make your finished product is clearly massively impactful upon when you release it. A simple clip together fixing or a simple bolt or a nut, usually in a shredding machine, that will release quite easily. But if you've made a really complicated composite sandwich with a thermosetting resin around 2 different types of fiber, and then sealed it with a sealant and covered it with a surface finish and put a load of unusual fixings that are fused in and welded together, you end up with these really, really clever uses of materials and probably solve the immediate issue that the designer wanted for lightness, stiffness, etc. But you've just made something that's impossible to ever recycle. It's just a future fuel as far as I'm concerned. So, and also, good design will help drive the product towards being able to deliver the end of life producer responsibility targets for cars and also WEEE, which I've repeated here. So if there's one real message that I would try and get to the designers and specifiers of materials, is this one, KISS, which I've changed a little bit. Keep it simple, specifier. And for me, you'd be looking and questioning, what's the shortest bill of materials that we could use to deliver the functional end life product? If we're going to use polymers, there may be several different types of polymers, but could we maybe keep all the textiles in one polymer and have all the rigid injection molded parts in another, and avoid a massive plethora of polymer choices from the, you know, the handbook of all the different polymer grades, and then choose 25 of them when you could have perhaps used 2. Clearly, I'm in favor of easy release fixings, where in a shredding or release operation, there's a clean release of the materials without one leaving its contamination on the other. So do away with fused in inserts and don't use so many glues, and have fixings with bolts and that which spring off when you try them. So there's a lot of good design here, but there's still quite a lot of bad design from my experience. And then if you can, when you make a component, an item, if that can be a single material component, or at least release into lots of individual material components, then that will really help the yield and the recovery of those materials at the end of life. And then the opposite of that is, you know, for me, I would really want to design a vehicle that avoided multi-layer composites, stay away from really complex connection methods, and paintings and coatings are pretty and nice, but they do make life hard for recyclers. However, as you can see, if you decide to stay 100% to Keith Freegard's rules of design, we may all end up driving something like this, where the bonnet's one big piece of probably vacuum formed polymer, and the sides of the car are nice flat simple bits, and the seats look really simple, and the wheels are nice and easy. I actually really like this car, you know, I love one of these, but I can accept that there's loads of other things that influence the design, and I'm not saying we should all be driving around in this type of vehicle, but maybe when we don't own vehicles and we just dial up a 4-person pod to take me to the swimming pool with 2 children and family, I won't be so bothered about the aesthetic design of it. I just want the functional service performance, and then maybe the design criteria and rules will change. So, what are the benefits of using these sustainable polymer materials? Because it's all well and good for me to come up with some, let's make a transition to the circular economy, let's save the planet. You have to offer products which can compete with what's already out there. And for me, some of the benefits are that nearly every leader of a well-known branded organization, particularly if they're making cars or washing machines or those material-hungry sectors, has stood up and said, not only are we going to be brand leader, not only are we going to deliver fantastic products, we are going to care for the planet, and we're going to be doing it in a sustainable way, and we're going to look at how green we can do this. And that goes in the annual company report. A couple of years later, they kind of say, well, what have we actually done? And if they say, well, we put a recycling bin next to the photocopier and we told people to use the train a bit more often, that's not exactly going to save the planet. What they really need to be asking questions like, oh, where are we now in terms of replacing oil-based polymers and mined raw materials in our products with those materials that have come from this circular economy? What percentage of recycled content have we got on plastic, steel, glass? Oh, sorry, again, clicked that the wrong way. Also, there's a risk argument here. Availability of a wide range of materials from all over the world, where different nations own the sources and the mines and the origins of those materials, creates a risk for supply. And if you can tap into a locally operated waste-based resource, so, you know, if I'm collecting cars in the UK, recycling them in the UK and selling those to molders and manufacturers in the UK, that feels like a much lower risk supply chain than the complicated ones we have for, say, titanium or antimony or even oil. Clearly, carbon impact is massive here, and I'll talk a bit more about that later, because that will become a metric in terms of judging materials in products. Cost savings, absolutely crucial, and very often we can give quite significant savings on recycled material versus virgin polymers. Being insulated from oil price volatility is a difficult one to sell to people, because many purchasers are absolutely locked into the idea that all their polymer parts will move up and down in value following maybe Platts or ICIS. They fully expect you to ring them up in 6 months and say, oh, now that piece of 1 kilogram plastic has gone up by 50% because of force majeure at the polypropylene plant in Germany. Well, if you own the whole waste capture and supply chain, you're completely isolated from all that horrible volatility and Platts and ICIS stuff, and I can just offer a customer a fixed price for the duration of the order that they give me. I think as consumers become more interested in the impact of the products they buy, they're starting to ask more difficult questions. The educated, knowledgeable consumer thinks really hard about what it is that's embodied in the product they're buying. I spoke with a company the other day who started selling storage boxes on an internet site, and they noticed that on the internet, the customer takes a little bit more time because they maybe have to compare offer A and type B and C. And when they promoted the boxes with the recycled content, they were selling a much higher percentage of recycled plastic boxes than they did in the store, which I think is quite an interesting lesson in where consumers buy and how they think. If you're sat on the sofa and you've got a bit of time to do a bit more valued comparison, maybe recycled wins more often in that basis. Also, if you start incorporating significant amounts of recycled known origin materials in your product, you are really preparing your range of materials and your huge material hungry supply chain for the time when carbon-based metrics and efficiency of your product will form the basis for taxation. That absolutely will come. And of course, you're driving forward with the circular economy, which is a desirable route that most people are aware of. I'm going to focus on one of those benefits in a little bit more detail. This is a study we did on our own factory for comparing the carbon impact of recycled materials with the carbon impact for virgin polymers, comparing polypropylene, ABS and HIPS. The scale up the side is that difficult to understand kilograms of CO2 emissions produced. So this is for 1 kilogram, and you can see that polypropylene has a just over 1.6 kilograms CO2 per kilogram produced. ABS has a much higher figure because you have to make 3 polymers, acryl, butane, styrene, combine them together in a much more energy intensive reaction. So that gets a really high impact figure. and HIP somewhere in the middle. And then these are the savings. They're absolutely vast. My green bars, which are done by the Carbon Trust system for analysing the system under my control on a like-for-like basis, the polymers are about the same because they're all mechanically recycled. So for ABS, the saving is absolutely huge, you know, maybe 3.3, 3.4 tons of carbon emissions per ton of material. What does all that mean? Because I know that nobody walks around knowing what a CO2 equivalent is. So I've worked this through to this example. Let's assume this lorry came last week and delivered 20 tons of virgin ABS polymer into my injection molding plant. And then I went in and I convinced the purchase manager to switch from his virgin ABS and go and buy some lovely Axe Poly low carbon ABS. Delivering 20 tons yields a saving of 20 times the 3.4 kilograms of CO2. Great big number. Still doesn't mean much. If the lorry then drove away from the factory and said, right, I'm going to keep driving this lorry, I'm going to count up the emissions impact of driving the lorry, because lorries do 8 miles per gallon of diesel. We can work out exactly how far the lorry will go if it used up all the savings that were achieved from just one 20-ton delivery. I'm putting a pause in so that you can all have a guess. And if you're in the audience now, I'd be asking people to guess. But 45,000 miles, it's absolutely vast. You know, that's what, 6 to 9 months operational time for one big road vehicle. So when these slightly ethereal CO2 equivalents get converted into pound note figures, the savings will be huge. Right, nearly into the time. Last few slides. What should you look for if you're trying to select someone to give you some recycled material? If you're absolutely convinced that the massive amount of benefits are a convincing thing, where do you go? What should you look for? Because you're moving into a new field here. You're not going to super multinational oil and petrochemical business who've got huge, great plants all over the world. You're probably dealing with a smaller, local, entrepreneurial recycler type person. So I would say that the things to really look for, where does the person get their feedstock? Is there some really reliable long-term urban mine that they're tapped into? If they're scrabbling around every week to buy a little bit of scrap from the nearest injection molding company, then I would steer miles away from that, because anyone who works as a parasite on industrial scrap is destined to disaster. Make sure that there's some sort of really integrated business model, that there's a degree of control and ownership all the way along the waste chain, from the origin of the waste and all the way through the material stewardship to start producing useful products. That will show a long-term investment, a secure supply. I call it going from the grave back to the cradle. Clearly, you want to be looking for people who are kind of ethical and got values and doing things right according to European legislation, employing people in the right way under a well-regulated environment. You don't really want to be importing stuff from overseas countries where the level of consideration for the environment and working standards may be much lower, and also some of the commercial ways of doing business are questionable. Make sure that there's a kind of respectable and stable history, that you're dealing with someone who's been around a long time. Look for really professional process engineering staff who know their process, know their materials, know all their stuff about yield strength, tensile strength, polymer chain length, branching. You want all that. And that will be evidenced quite often by a real commitment to quality, safety, and environmental measures, and ask them for their certificates, ask them for the last audit, ask to see their testing house, ask to see their quality records. Make sure that you give yourself a nice, comfortable feeling when you visited the supplier. And one really good place to start is at the BPS Find a Recycler site. So in there, you'll get a list of about 40 or 50 companies in all different sectors of polymers. I'd recommend taking a look at that area. We're nearly done. Let's, if I was in the audience, if I was now and you're there in the audience now, I'd be looking around the audience to see if anyone was nodding off a bit, and I might raise my voice, but As I can't do that, I'll assume that everyone is still wide awake, fully engaged with my talk. Here's an image of the future I found, which was an article on assuming this is an electric Volkswagen. It could be hydrogen fueled, I suppose, and it's in a suitably modern environment. It's a little bit worrying that there's no people around. Let's not hope that's not our future. So what do I think the future might hold if we roll this story forwards now from where we are with this sort of partial transition to a circular economy to a future where we change technology in cars, much more digitally based, people really aware and understanding of materials and their importance, then I think we will certainly see that the access to good quality materials will mean that as the population grows, we're going to have a huge demand on some of the sources of materials, and that will drive up value. So some materials will become much more scarce. I believe that some countries will begin to understand the importance of carbon metrics to drive both their waste recycling sector and also to measure and control the costs and choices made when energy and material hungry industries use up materials. And that when that happens, when carbon equals pound notes, we will see some huge changes. We will get to a point where product life cycles, as I pointed out with my electric vehicle charged entirely on renewable electricity, is entirely based on the bill of materials and the choices at the design stage. I think we'll start to see better design products, which are not just about aesthetics and sales and glossiness and techo-ness and, oh, isn't it appealing, isn't it lovely, isn't it pretty? Materials that actually really think about how they're going to be yielded and extracted at the end of life. I think we see more business models where organizations who own the materials when they built the product will want to own that material when it becomes available at end of life. It's already happening in things like motive power batteries for cars, where there's loads of cadmium, lithium, leadmium in the battery, and they're really expensive. It makes sense for the owners of those materials to get those big lumps of valuable materials back. And we'll see that business model come in a lot more. I think we'll start to see integration between manufacturers and the recycling sector. And we've already seen that in some areas where manufacturing businesses have taken over recyclers to gain the know-how, the knowledge, that kind of entrepreneurial zeal that makes them do really amazing things. And then, of course, that will start to drive the design itself. If manufacturers had to take apart the products they'd made a few years before, they would think a lot more about the design. I think we could certainly get to an area where 75% of new product materials are made from recovered previous use materials and avoid our dependence on digging things out of the ground and drilling them out of wells. And also, I think that these new business models will really reinforce the relationship between users of products, which are usually delivering a service like transportation, clothes washing, whatever, and that service provision from a brand you trust and a brand that's ethical, cares about the world, cares about materials will be strong. I'll stop talking now. I'm sat in my little room in Manchester and I've finished my presentation. So if people have questions, I've got a bit of time now to take those. Thank you.
Okay, great. Thanks, Keith. Yeah, thank you very much for that. We do have a few interesting questions in, which I'll go straight into now. First one is, are there any safety critical vehicle components where recycled plastic cannot be used?
That's a very astute question. I'm sure there are safety critical vehicle components where the need of the designer to check the performance of the polymer and the way it behaves in its life cycle and its performance is really critical. And I wouldn't just assume that you cannot use recycled materials in those products, because there's very good evidence that well recycled polymer from well controlled waste streams can deliver long-term physical performance in the second life and even the next life. So clearly the potential risk is higher. But in my view, if that product needs a polymer with a tensile strength, a yield strength, an impact strength, and to be stable for a known number of years, and it can pass those tests, for me, I see no reason why a well-tested, well-certified, proven recycled material cannot be used in the same position as a virgin polymer material.
Okay, great, thanks. Next question says, my understanding is that there is pressure on automotive manufacturers to lightweight their components to reduce CO2 emissions. How do you persuade them not to move towards FRP, etc.?
That's very difficult, because I think that the legislative structure that's been set up to try and drive automotive design down a route of reduced emissions is obviously very laudable, and we're only part way along that route at the moment, because we still have, London, where I live at home, has got always breaking all the local emissions rules. Many towns, Paris, etc., Rome, all got this big problem of emissions. So that story has to roll on, and I think lightweighting is a critical part of that. My understanding is they're getting into the ranges of limited extra benefit, a marginal improvement now, and I question whether, if you take a small, very efficient, modern, small hatchback delivering quite amazing miles per gallon. I mean, 60 miles per gallon out of vehicles driven in a really economical way is not that unusual these days. 10 years ago, they'd have not believed it. So with very low consumption, really good control of the combustion in the engine, really good control of the particulates in the exhaust with filters, etc. I think we maybe have gone as far as we need to go with the internal combustion engine. And what we should now be rolling forward on is looking at what factors are needed in that different balance of metrics around EVs and electric vehicles, which would be charged with a much higher proportion of renewable energy. Lightweighting is still important, but actually in the EV, it seems to me, it's really the battery which is the big heavy bit. You do want kind of a stiff, lightweight box that holds the battery, but the new EV is a sort of piece of waste electrical equipment, not really a car anymore. It's sort of motors, battery, distribution of power, a bit of steerage, and a load of IT to steer the thing. But I think that the choice now needs to change and take on more of what are the embedded impacts of what came? Does it contribute to lightweighting in the actual lifetime of the product and therefore make the EV go farther? But also, what are we going to do with this valuable material at end of life? So for me, just focusing on lightweighting is only looking at one of those issues, and I don't think that's the full story in a modern design environment.
Wow. Okay, great, thanks. Next question then is, how do you verify that the quality of the polymer is as good as virgin material?
The polymer quality thing is pretty much about making sure that your recycled polymer producer has got a proper polymers lab on site, and they're doing proper polymer testing with all the standard ISO tests. So, visit the site, go in there and work out who you're dealing with, and you should be impressed with the laboratory, the standards, the data, the historical background. Ask them difficult questions, look at other products they've produced. Most polymer producers will have a range of things that have been made, different shapes and product components. And then if need be, subject them to some really tough testing, do some accelerated aging test with rainwater and UV and oxidation, etc. And I know that from the response we get from many of our customers, once the industry has begun to switch over to the idea that, hey, these recycled materials are really pretty good, then the quality question goes hand in hand with that. And the big suppliers who survive and deliver good stuff have got all the certification, the testing and the background to back it up. So treat the recycler like you would any provider of material and make sure they can answer those difficult quality assurance questions.
Okay, thank you. Great. All right, and final question then we have is what is the security of ongoing supply of as volume demand increases? So how do you ensure the security of ongoing supply as the volume demand increases?
Yeah, that's a good question, because the sort of typical pattern that I observe is that recyclers tend to be smaller entrepreneurial businesses who've grown rapidly over 10 or 15 years, as we have. And if you map them against the typical size of organization that delivers polymers, if you're a multinational polymer company who's linked to a multinational oil business, then you've got a huge worldwide footprint of supply, and that gives huge volume and huge security. And I can see that people might say, well, you know, when we've used up all of that local supplier stuff, what are we going to do? So I think to begin with, start smaller and look at things that are well within the scope of the person you're dealing with. But what I do think is happening is that we're beginning to see either polymer producers, the traditional oil-based petrochems, moving into this space and forming allegiances and taking over waste management companies and taking them under their wing, at which point we will begin to see many more part recycled blends being made and produced by the virgin polymer producers to address the need in the market. Or on the other side, we're also seeing big manufacturers acquiring recyclers and then integrating that supply into their own range of materials. We've seen that with RPC and BPI in the last year, where RPC, the big packaging producing company, is acquired one of the largest UK plastics recycles British polythene industry. So the market structure and the shape of companies are changing, and I think that will address the demand issue as the volume grows.
Right, I see. Okay, brilliant. All right, that's it. I don't think we've got any more questions written in at the moment. Keith, did you have anything else to add?
No, I think I've spoken long enough. But
right.
if there's anyone out there who is excited and interested by what I've got to say, then I'm always happy to engage with organisations and companies, and you know, if they want to learn a bit more about how do we get the circular economy going, or how can we address design. If any of the things I touched on in my presentation strike a chord, then please don't hesitate to make contact with the details I've got here outside of this. And you know, we'd love to engage with manufacturers because we want to drive forward the circular economy, and I really care passionately about making sure that we address some of those big global issues that we've got in the world at the moment. Thanks.
Yeah, brilliant. Yeah, thank you very much, Keith. And if you wanted to forward this webinar, or people who've tuned in, to any of your colleagues, it will be available online on the BPF website in the sort of webinar section. So you can go there and watch it and forward it on to people that missed it. Thank you very much, everyone, for taking part, and join us next time we have a Lunch and Learn webinar. I think we'll have another one on this sort of broader sustainability topic, which hopefully you'll be made aware of either by email or by checking into the website. So thank you, and have a good day.